Let's start. Yeah, recording started. So, a relation, binary relation on any set S is said to be partial ordering or partial order if it is satisfying three properties: reflexive, antisymmetric, and transitive, that we have seen during our last two lectures. Further to this, I have told you a set on which relation R has been defined. So a set S together with a partial ordering relation R is called a partially ordered set or POSET, that we have seen. Now, the point to consider is here you are observing a less than equal to. So this is the symbol used for representing a relation. It may not be less than equal to relation. If we are representing a POSET, the POSET is generally represented using set comma less than equal to. This less than equal to indicate the type of relation present on that particular set. I hope this is clear. Further to this, this is something new that I think I have not covered. If we are observing any two elements of a POSET S comma less than equal to, those two elements are A and B. Those elements will be said to be comparable. You can compare those two elements with each other. Elements from the relation, partial ordering relation, are said to be comparable if you are having some kind of association in between those two elements. For example, you can say A is less than equal to B or B is less than equal to A. Okay. There should be some hierarchy. A and B, any two elements should not be placed on the same level. There should be some sort of comparison, either lower level, higher level, or vice versa. If that is not the case, we will say that A and B are incomparable. Further to that, we had a discussion on this partial ordering set, and every two elements of S are comparable. If that is the case, I told it in terms of chain. Okay. If we are able to relate all the elements of a set on which relation R has been defined using some manner, then that particular set is called totally ordered or linearly ordered set. Further to that, a totally ordered set is said to be a chain. Do not get confused with the definitions. I am going to post these PPTs on your classroom in the due course of time, okay, before your exam starts for the preparation. Okay. Further to that, we have seen partial ordering relations can be represented using Hasse diagrams. So, you can draw a normal diagram, but we can make it simpler using the concept of Hasse diagram that we have seen. No? So these are the rules that we will be following while drawing a Hasse diagram. We will be starting with a directed graph as like your diagram with all arrows and everything. Then we are going to eliminate the self-loops. Then we will remove all the arrows, especially the arcs which are representing a transitive property will also be removed. And the direction indicators on the arrows that you are writing arrow towards one point or the other, that will also be removed. Okay. Further to this example you can cross check. Okay. I think I have not taken this example, so if you want, you can have note of this as well simultaneously. I'm not going to discuss. I'm just giving you an overview of what we have seen in the last two lectures. So let A be a set having these elements, and you have been given a relation that is divides. How to interpret this divides relation? We will say for all A comma B belonging to original set A, we will have A divided by B is equal to 0. This is interpreted in terms of this. A divides B is implicable to B equal to KA for some integer K. In simpler way, if it is given that consider the divides relation, you have to relate it to A slash B. Okay. B divides A, like this. So we can check 1 1, 1 3, 118, 1 2, 1 9, then 318, 3 9, 9 18, and everything is present. Okay, this is normal diagram for the relation R. Okay, I will tell you what will be the general pairs in R. We will have all self loops then whether 2 is divided by 1, yes, so I will say 1 comma, sorry, 2 comma 1, no? If we are taking like b upon a, if we are taking a upon b, you could say okay, 2 upon 1, and if you are thinking of b upon a, you can say 1 upon 2, like this. Further to that, if we will have 3 9, then I will say I'm going to have, okay, instead of this 18, okay, this is mistake, consider it as 18, not 19, okay? Otherwise you would have confusion. This one is 18, so let me make it correct for your understanding, otherwise you will take the things. This is not the case. Instead of this, I will type it. So you could observe everything is dividing. 3 is also dividing 18, 9 is also dividing 18, and so on. So we are left with this diagram. This is converted into hash diagram using this notation. So 1 is the lowest element placed at the bottom. Then I am having hierarchical classification. 2 and 3 are not at all related with each other. They can be placed anywhere. Doesn't mean that you are placing 2 above 3. This can happen only if you can compare 2 and 3, but there doesn't exist any relationship in between 2 and 3. Further to this, we are observing 18 is lying at the top. How many we are having now? 52. Okay, fine. So this is the hash diagram which is converted from this complicated diagram. This is much simpler origin. For this POSET, again I am giving you examples. Okay, the relationship is divides by. If such example is given in examination, you should not confuse or you should not think that this has not been taken to us. This is a set, and what is the relation? Divides. So you have to make pairs which are completely dividing each other. Samiksha Kate, whether she is Samiksha Kate, Samiksha, are you there?
Sir, it's my account, sir.
Yes, who is this?
Sir, it's my account. I'm joining from another device.
Okay, okay, no problem. The POSET, this, see, the diagraph will be very complicated. You can observe. How can we make it simpler? Simply draw a hash diagram. So this is the simplest representation of given relation, which is a divides. Okay. I would suggest you to take these examples as snapshots, and you can try them as an exercise and check out whether you are getting the same hash diagram as the result. No problem. This relation is divides by, A divides B, like this. Next, this one more example. This we have, I think, discussed 2, 3, 5, and has a diagram of power set of S, subset. So you can see I'm starting with phi. This phi is subset of all the individual elements 2, 3, 5. These will be the members of power set. Further to that, we will say 2 is subset of 2, 3. 3 is also subset of 2, 3. 2 is subset of 2, 5, and so on. Finally, you will have your original set S at the top. This is the hash diagram for this particular POSET. POSET is our set of S, relation is subset of. And further, check out this new thing. For this reason, I have started with slides for today. Okay. They will simply ask you DN or D30. What is this meaning of this D30 or DN? If this symbolic representation is given in examination, this is indicating that this is a POSET with set of all integers that divide n. In this case, let us say 30, and the relation is divides by. Are you getting my point? What this is? What will be D30? D stands for divides by. Okay. D30 is a set of all integers from 1 to 30 in such a manner that Okay, all these numbers are dividing 30 by integers. You can see indicates the POSET with the set of all integers that divide n. N in this case is 30 and the relation is divided by. There should not be any remainder. So let us check out. This is the hash diagram for this. Okay, yes, D30. One, whether 1 divides 30? Yes. Whether 2 divides 30? Yes. I can say my pair is 1 comma. In that case, I have to take it like, okay, b upon a. Let b be 30 and a is a number which is dividing b. So our relation is b upon a. Okay? Try to remember. 1, 30, 2, 30, 6, 30, 10, 30, 15, 30, 5, 30 and so on. So these are related with each other. Again, divides relation. Good. I think this need to be cleared one more with more emphasis. Otherwise, you will have this in your mind forever. Just a second. Okay, this B 30. B30 is a set of all integers. 1, 2, 3, 5, 6, 10, 15, and 30. Set of all integers which divides 30. And what is our POSET? POSET is B30 comma divides. So now you are going to write the relation. What is the relation? What are the pairs in relation? You are going to apply this divides relation for this. Okay, for these elements. So I will have first pair whether 1 divides 1, yes. Whether 1 divides 2, yes. Whether 1 divides 3, yes. It is going to divide everything 1. Okay. Further, what can I write? Can I write like 2 comma 6? Yes, it is possible. Can I write like 2 comma 10? Yes, it is possible. Can I write like 2 comma 13? Yes, it is also possible. And you would have further extensions. Further to that, you would have 15 comma 15. You would have 15 comma 30 and so on. How I am representing a relation? Relation is B upon A. You can have A upon B as well. Divide something. This is simply divides. Someone is dividing someone other. That is a kind of relation. Okay. So in this case, it is clear. One is dividing 2. One is dividing 3 and so on. So for this relation, we are drawing the hash diagram. What is the hash diagram? This one. E30 is indicating set of integers which are dividing. In general, if it is given dn, it will indicate the set of all integers that divide that particular n. I hope I am clear. And this is the today's point of discussion. Up till now, you have learned lot many things, and we are now going to play with all the diagrams that we have studied so far. So, have you heard of upper bound, lower bound concept before? Can you turn on your mic and say yes or no? Someone. Have you heard of upper bounds and lower bounds before? Do not go with the slide. Okay? I am going to explain what this is. Have you heard of at least yes or no? Upper bound, lower bound, something like that. Yes. Okay. So now we are going to discuss about related to graphs. So have you studied graphs before? In what standard? In which mathematics you have studied graphs? Okay, whatever it may be. So we are having that concept. So observe, there are two types of extremal elements, something maximum or something minimum. I will go for high or low. So extremal elements, what are the maximal elements? We are defining all this in the context of hash diagram that we have recently seen. An element small a in the POSET s comma less than equal to will be said to be maximal. It is the maximum if there is no element small b in that S which exists such that we could have a relation a less than equal to b. In short, a maximum element is the element which resides at the topmost level in the given hash diagram. If you are having more than one elements lying at the topmost level, you will say that all those are the maximal elements of a given hash diagram. I hope I am clear. If there is one unique maximal element, it is called as maximum element or the greatest element. Okay. Otherwise, if you are having multiple maximal elements, those will be represented in a set. We are going to see the example so that things will be clear. Okay. Let me talk about this hash diagram. Okay. This one. So what is the maximal element for this hash diagram? You could observe 30 is present at the topmost level. So 30 is the maximal element as well as it is the maximum element. As this is 1, it is maximum as well as maximum. Its counterpart is minimal element or minimum element. This one is minimal, which is lying at the bottommost level. This one is maximum. Okay. Let me make it clear. Maximum. Okay. Do we have any other? Yeah. Can you tell me what are the maximal elements for this hash diagram? Can you tell me? Be quick. I'm talking about this hash diagram. What are the maximal elements for this? The elements which are maximal. I am asking maximal elements for this hash diagram. Pratham, do not get confused with the upper bound and lower bound. I have not discussed anything about lower bound and upper bound. Just observe in this hash diagram, 8 and 12 are lying at the maximum level. There is nothing above 8 and 12. So set 8, 12 is known as maximal elements. Are you ready? 8 and 12 both. 8 and 12 both. Those who are saying only 12, see, there is no relationship in between 8 and 12. You cannot compare 8 and 12 for this example. Hence, both are lying at the same level. Hence, both are maximal elements. Okay. We are not taking which one is lower and which one is higher. I am asking out simply, check out the levels. Level 0, level 1, level 2, level 3. Beyond level 3, there is no element. So I am saying 8 as well as 12 are maximum. And what one is minimal? In this case, there is only one minimal element, which is 1. Am I clear? Okay, fine. This is the counterpart of definition of minimal element. So an element small e in a POSET will be said to be minimal if there doesn't exist any b such that b is less than. I mean to say there should not be any element downwards, your minimal element. In that case, that particular element will be said to be minimal element. And if we are having only one unique minimal element, we would say it as a minimum element or the least element. Try to understand the definition. Least element and greatest element. Are you ready? Okay. So questions for you. Can you tell me what are the maximal elements and minimal elements for this example as well as this example quickly? Can you tell me what are the maximal elements for this diagram? Max is H. See, again you are making confusion. Okay, making confusion again. Okay. Try to understand the definition. An element. Okay, you could have multiple elements. No problem. I have not asked you what is the maximum element. I am asking you what is maximal element. There can be more than one maximal elements as well. You would say, try to recollect this definition. Recall. You will say that any element is a maximal if there is no other element such that you could have such a relationship and that element is lying on the top of selected element. That is the definition of maximal. How can you are saying like only H? I do not understand. Okay. How many levels are present for this example? Level 1, level 2, level 3. Are you ready? Only 3 levels. I am asking for this first. Okay, afterwards we will go for this. I know that for second H is maximal and minimal is A comma B. Perfectly fine for 2. Okay. Yeah. Fine, fine, fine. For this first example, G, H, I are lying on the same level and there is no other element here which is present which is above these. So obviously we can say that we will be able to identify this GHI to be maximal elements and A, B, C which are lying down are known as minimal elements. Are you ready? For this example, I am clearly observing that this element H is present at the topmost level, so it is maximal element, while A and B are present at the bottommost levels, so these are known as minimal elements. Am I clear? Should we proceed? There should not be any confusion. No? No maximum, no minimum. Correct, Aditya. If you are having multiple maximal elements and minimal elements, you are not able to identify any unique element which will be minimum or maximum. But for this case, you could observe H is the only element which is maximum. So it will be maximum element as well. Correct. Am I clear? Okay, fine. Fine. Now be careful. Okay. Be very careful about these definitions. These will help you to solve all your further problems. So let again S comma less than equal to be a poset, and let we are having some set A which is subset of S. If U is an element of S such that A is less than equal to U, or all small a belongs to A, then we would say U is an upper bound of A. Read out this definition carefully. So if we have been given a poset and if we have been given further a subset set of elements, and we have been asked, can you compute what is the upper bound of this subset in the context of given poset, we will be looking out for all such elements wherein I can relate the elements of given subset with that particular element U. Then I will say that U is acting as an upper bound of set E. Further to that, we are having a concept known as least upper bound, not greatest, least upper bound. In case we are having multiple upper bounds for a given pair of elements in the hash diagram, you are going to choose the upper bound which is at the lowest level in the context of given pair of elements. That upper bound will be known as least upper bound. In short, LUB, least upper bound. I'm quite sure that you will not be able to make a sense properly unless and until we cover up this with the help of example. So for a while, I will tell you how to remember what we mean the upper bound. You have to take all those elements which are lying at the higher level than the given elements. But there should be some relationship in between elements present at the higher level and elements which are given. Amongst them, you are going to again check out which one is lying at the lowest level, and that will be known as least upper bound, LUB. The counterpart of it is lower bound. In this case, we are going to check elements lying on the downside of a given pair, and out of that, whichever element is lying at the immediate downside, we would say that element as greatest lower bound, GLB. I would suggest you to have these snapshots somewhere for your reference. I will explain this with the help of example. Both these snapshots. Yeah. We will be solving around 4 to 5 examples based on this topic. I would suggest you to first look out how I am solving this first example, and thereafter you can try for others. So we have been provided with this hazard diagram, and the question is find least upper bound and greatest lower bound for pairs A, F, C, E, B, D respectively. Okay. So first of all, it is A comma F. So I will explain this in notepad. It will be more proper, more channelized. One. What is this? Find LUB of A comma F and GLB of A comma F. So before going for least upper bound and greatest lower bound, we will write upper bounds for A comma F. What are the upper bounds for A comma F? Just check. For A comma F, the immediate upper bound is B. B's upper bound is C. C's upper bound is D. D's upper bound is again E and D. So what are the upper bounds for this? We are having first upper bound of A comma F as B. I will say C, E and D. These are the upper bounds for A comma F. Further to that, it is asked what is least upper bound of A comma. So you have to relate B, C, E, D. B is present at the lowest level in comparison with C, E as well as the D. So I will say least upper bound of A comma F is further. I will say lower bounds for A comma. Let us check out. Is there any element which is lying at the bottom A and F? There is no any element below A and F. So what is the lower bound of A comma F? It is empty set. 5, nothing. If there is nothing, what will be greatest lower bound of A comma F? Nothing. Greatest lower bound does not exist for this example. Whether it is making any sense or any confusion, can you reply in the chat box if it is clear? Whether it is clear, whatever I am saying. There is question from Prathamesh. Is E minimal in first part? Where? In first part. Where? Which example, Prathamesh, you are talking about? E minimal in first part? Previous question. Okay. I have not seen. Okay, let me check. Previous question. Which? This one. This one? This one? You are talking this example or this example?
First part, sir. First, in which maximal is GHI.
Okay. In this part, GHI is maximal, isn't it? And DEF is lying at the level 1. Below that, we are having other elements A, B, C. So these are the minimum elements and not E. We are having A, comma B, comma C as minimum, not E.
Sir, but if we look at A, B, and C, then we can clear with that we can notice that A, B, and C, these any other element is not related to A, B, and C.
Indeed, yes, correct. But that will be the concept of upper bound and lower bound. Presently, okay, this example was given in the context of maximal element and minimal element. So when we talk about upper bound and lower bound, your idea will be clear, okay, about this example as well. I think you are getting confused with the definition or usage of upper bounds and lower bounds in this context.
It is seen that A, B in comparing A, B, and C, no other element is related to A, B, and C respectively. Such in way that for E also any other element is not related to E.
Yes, default, yes, no problem. But D, E, F are present at the same level, and you can observe this D, which is present on the level of E, as well as F present on the level of E, are having some relationship with the bottom elements, like B is related with F and B is related with D. How can you say? And further to that, this H is related with A. H is also related with C, and those are on the downline. Huh? So you mean to say A, B, C, and E are minimal? That is your question?
Yes, sir.
Yes, yes, yes. As per the definition, okay, you will. I will. No problem. So in this example, we will have E as well. Yes, his point is correct. Okay. If there is no such relationship in the context of other elements, you could observe E is not related with any other element which is present on the downwards level. While this F and D are related, there exists a element. If we consider only E, there is no any other element which is below E because of any relationship. So for this case, you will have four minimal elements A, B, C as well as E. Now whether it's clear? Yes.
Yes, sir. Fine.
Okay. Others, what is your opinion? Are you waiting why E will be there for the last example? Whether it is fine? Girls, whether it's clear? Okay, fine. Fine. I have forgotten to mention. Fine. That is quite good. Okay. So for this A comma F, I told you about this. You will have least upper bound as B and greatest lower bound will be Y. Can you tell me quickly what will be the least upper bound of pair C comma E and greatest lower bound of pair C comma E? Can you tell me quickly for B? Already we have seen for A. C E. C E D. D. What is this, Swapnil? Whether it is greatest lower bound or least upper bound? Least upper bound is D. You are saying okay. Let me check out CE. Yeah, there is only one upper bound which is a D in the context of this C and E, and that is also a greatest, sorry, least upper bound, no? Not greatest. And for pair C comma E, how many lower bounds exist? A, F, B. Out of that, which one is greatest? B. So this will be GLB for pair C comma E. GLB. Is it clear? Let me try to first write the solution for at least this first example. Others you can try it because there could be someone who is not getting a clear idea, and for them I need to write GLB. These examples are asked for 6 marks in your final exam. They will provide you a hash diagram and ask you to compute least upper bound and greatest lower. So first of all, upper bounds of C comma E. What are the upper bounds? I am observing only D. So obviously this will be least upper bound, LUB, C comma E. It will be itself. Lower bounds of C comma E. Here I am observing that there are 3 lower bounds, B, A, F, and out of that, which one is greatest lower bound? Greatest is B. Third one, we will solve simultaneously. Least upper bound of, what is asked? Least upper bound of BD. This one is B and D. Someone B comma D. And GLB of B comma D. Can you tell me what are the upper bounds of B comma D? What are the upper bounds of B comma D? For this example, what are the upper bounds? B comma D. In the context of B, okay. So upper bounds of B are C, E, D. Upper bounds are of D are, there is nothing upper to D. Ready? So what are the upper bounds of B and D? I will say upper bound of pair B comma D is D. upper bound of B comma D, D. East upper bound of B comma D, D. Lower bound of B comma D, B, A, F. Greatest lower bound of B comma D. Can I say like this? Can we say like this? Okay, 5 will not come. 5 will not come. Why? For D there is nothing. Okay. While computing upper bounds for pair B, D, you are looking for both elements B as well as D. For B, I am observing that upper bounds are C as well as E, and because of transitivity, B, C, C, D, I am obviously having a relation B to D. So D is an upper bound of B. In this similar manner, here B to E, E to D, B is an upper bound of D as well. How come you will have 5? We are going to have this for pair B comma D, D as an upper bound. There is no upper bound for D, perfectly fine. But if I am observing a pair B comma D, I mean to say it is, and for a pair B comma D, you are going to have that as a least upper bound. In the similar manner, for lower bound, you will have 3 B comma E comma F. Out of that, D is acting as the greatest lower bound. I hope this is clear. In case of steel, there is a problem. You can discuss. Moving forward. Now this is up to you. Okay. Tell me about this. So question is find LUB and GLB for 6, 7, 10. 6, 7, 10. Which one? Should I explain this? Should I explain this? 6, 7, 10, or will you be able to compute? I will explain no problem. So observe. First of all, upper bounds of 6, 7, 10. What are the upper bounds of 6, 7, 10? 10 and 11 are the upper bounds of 6, 7, 10. Are you clear? Whether this is clear? Only 2 elements will be acting as the upper bounds of 6, 7, 10. Those are 10 and 11. We will not have 9 because 9 is not related with 7 by any means. Right? So out of these 11 and 10, which one is least? 10 is the least upper bound. So you will have 10 as the least upper bound of 6, 7, 10. Whether it is clear or still confusion? See, you are always thinking upon less than relation, but the relation is less than equal to. So you may have equal to as well, and you have to consider that equal to in every aspect while taking out these hierarchies. An element is upper bound as well as lower bound of itself. So for this case, least upper bound of 6, 7, 10. 6, 7, 10. This will be least upper bound. LUB. And whatever I have highlighted in this red color, these are acting as upper bounds. Out of that, this one is least. Let us now check which are the lower bounds. 6, 7, 10. Okay. So is there any relationship? I will not say about anything about this 3, but I will say 4 is one lower bound of 6, 7, 10. Then 1 will be another lower bound of 6, 7, 10. Out of these, which one is greatest? 4 is greatest. So this will be greatest lower bound of 6, 7. Am I clear? In case of problem, turn on your mic and tell me. You can discuss freely. GLB4, yes, GLB4. And how about LUB? LUB, I have shown you 10. It will not be 11. GLB is clear. Then why this upper bound is not clear? Clear. Fine. 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 How about others? Whether it is clear? Should I give you one more example? I do have many examples to make you confused. So let me ask you, what are the LUB and GLB for pair 5, 6? So I am writing this pair here. Pair is 5, 6. You have to tell me quickly. Both GLB as well as LUB. 5, 6. Can you tell me? Five, 6. If we consider 5, 6, what are the upper bounds of 5, 6? We will have 9, 11. Okay, 9, 11. 9 and 11. Out of these, you could observe 9 is least upper bound. Somebody has given, yeah. Yes, Shraddha, correct. And okay, if I am interested in lower bounds of 5, 6, I will say, can we say 2 is a lower bound of 5, 6? Is reply. Can we say 2 is a lower bound of 5, 6? No. That means you have understood. Okay. So only we are going to have a relationship. 5 is related with 1. In this similar manner, 6 is related with 1. So only this one. This is acting as lower bound as well as greatest lower one. Pair 5, 6. Can you check for this? Can you check for this? Be fast. Many more examples to take. What is this? Let set x is 2, 3, 6, 12, 24, 36, and a relation less than equal to is defined as if x divides 1. That is the relation. So you need to first draw the hash diagram. Then you will be telling me what are the maximal elements, what are the minimal elements. You will be further telling me any example of chain and anti-chain. And further to that, we will have consideration on what will be the maximum length of any chain. Famous question. Okay, for 6 months. Quick. Tell me what are the maximal elements and minimal elements. Mahesh, can you tell me what are the maximal elements for this hash diagram? Okay, before we proceed, tell me how many pairs your relation will have. All are solving. Okay, fine. Nothing in chat box. That means people are trying. I will try on my side. Okay. Let me check out if it works fine. So, what do we do now? So I guess we have been provided with 2, 3, 6, 12, 24, 36, and relation is x is dividing by 5. So is there any relationship between the 2 and 3? I will say I will have 2. Let us have 3 somewhere. There is no relation. You can draw 2 and 3 on the same line as well. It is up to you. Okay. Next I am observing 6. Okay. And there will be relationship in between 2, 6 as well as, sorry, above 6 I have to have 12 somewhere. So I will say 12, about 12, 24, 36. So can I place 24, 36 on same line? Yes, it is up to me because 24 and 36 will not be related with each other by any means. So you can place. This is like 120, you make that. Let me have 36 somewhere. So these are the elements which are present in my original set. Now let me try to draw the arcs. I am drawing hash diagram. So 2 to 6, 2 to 12, 6 to 12, 6 to 24, 6 to 36. This is the hash diagram, which is correct, I think. Okay, divides by relation. So let us check out whether transitivity is implied by default. You will have pair 2, comma 2. So self loop is omitted. You will have pair 2, comma 6 and 6, comma 12. So 2, comma 12 is implied by default that we are observing. Okay? That is observed by default. These are the nodes that we have. I think all of you are now having answers with you, which are ready. So can you tell me what are the maximal elements for this hash diagram? Yeah, relation. Viraj has given the relation. Very good. Okay, no problem. 2, 6. I think Viraj, you have forgotten putting out self loops as well. In the relation, you must have everything. Yeah, you have put 2, 2, 3, 3, 6, 6, 12, 12. Yeah, fine. That is the relation. Question is, what are the maximal elements? So I am observing that there are two elements, 24 and 36, above which there is no any other element. So 24, comma 36 are the maximal elements. So we are having 24 and 36. These are the maximum. Okay. Next, it is asked what are the minimal elements. So we will have 2, comma 3. Both may or may not lie on the same line, but they are not at all related. They are not comparable. So 2 comma 3 are meaning. Give one example of chain and one example of anti-chain. I have discussed chain and anti-chain. Which one is chain? I'm waiting for chain and anti-chain. Okay, chain. 612. Yes, you can have any chain. Okay, it is up to any one example. 612 you are given, and you are saying anti-chain is no. 312 will not be anti-chain, Prathamesh. What do you mean by anti-chain? Elements must not be related with each other by any means. No any intermediate station as well. There should not be any bus for reaching out to that destination from the given source. That is the meaning of anti-chain. So I could say, okay. And in hash diagram, I will be moving upwards only, no downwards. So if you observe 2 and 3, they are not related with each other. You cannot say 2 with 6 and 6 with 3. There is no such relation. No? So 2, 3, an example of anti-chain, or you can say 24, 36 is another example of anti-chain. Yes. And for chain, you could have any. You can say 6, 12. I can say 2, 6, 12, 24, 2, 6, 12, 36, 3, 6, 12, 24, 3, 6, 12, 36, and so on. What is asked further? What is the maximum length of chain? What is the maximum length of chain? Maximum length, you need to count the number of edges present in between source to the final destination. So I could say 2 to 6, 6 to 12, 12 to 24. 1, 2, 3. 3 is the maximum length. 3 is the maximum length of any chain in this hash diagram. Yeah, fine. Should we proceed with the one last example? Should we proceed? Do you want me to continue with the last example? So give lower oblique upper bounds and greatest lower bound and least upper bound of the sets DEF, AC and BD. Now this is confusing, challenging, as well as it is covering everything. Think over it and let me know your final answers. If we observe pair D, E, F, what are the lower bounds of D, E, F? Remember that while computing either lower bound or upper bound, all the elements should be related with something down the line. Otherwise, there will not be any lower bound or upper bound. Yes, if we observe pair D, E, F, what are the lower bounds of D, E, F? For D and F, lower bound is B. For E, there is no any relationship. So I cannot define any lower bound for D, E, Right. So lower bound for entire pair D, E, F is 5. You will say me, sir, why this is not the B? Because there is no relationship in between E and B. So I am not going to consider B as a upper bound or lower bound of E and B may lie on the same line. And how you can say B is a lower bound of E? Only because of this diagram? No, that is not allowed. So this will be fine. Yeah, fine, correct. For DEF, lower least upper bound is 5 as well as greatest lower bound is also 5. Again, why? E is related with G and I. D is only related with G. So we cannot say for this D, I will act as an upper bound. Okay? And in the similar manner, I cannot say anything with respect to G by considering F. Just observe. For DEF, lower bounds. There is no lower bound for entire pair D, comma E, comma F. So you will not have any greatest lower bound. In this similar manner, there is no any upper bound for pair D, comma E, comma. Upper bounds exist, but G, H, and I, there is nothing in common for all three elements. So it is fine. Okay. For AC, what is the answer for AC? Can you tell me for AC? For A, comma C, we can clearly observe A is also related with H and C is also related with H. Okay, so H is the least upper bound of pair A, comma C, and there is nothing downwards to A and C. So there will not be any concept of lower bound in the context of A, comma C. So upper bound, least upper bound for A, comma C is H, and greatest lower bound is 5. Okay, for B, comma D, BD, let us check out BD. For BD, lower bounds of BD, lower bound is B. These are related, and greatest lower bound is B itself. Similar manner, upper bounds of DG, upper bounds are DG, out of that, least upper bound is D. Try to understand this. If I observe a pair B, comma D, BD, what are the upper bounds of BD? We are having upper bounds like G and D. Okay, D is upper bound of B and G is upper bound of D. So out of this D and G, which one is least? D. D is acting as least upper bound. And if I go downwards, DB, what are the lower bounds of BD? For D, we are having lower bound as B. This I was trying to explain in the last example as well, wherein you have said that you are going to have phi as the result. No, you will have this as a result. Is it fine? Is it fine?